Hi, today we're going to be adding and subtracting rational expressions. We're going to first start off with the use what you know, and again go back to when you first added fractions and subtracted fractions. So problem 1, how do you add 3/4 plus 5/6, again without using your calculator? A common mistake is students want to go ahead and add the 3 plus 5 right now. But if you recall, when you add or subtract with fractions, you need to have a common denominator. So that means that we have to get the 4 denominator and the 6 denominator to change them to equivalent fractions so they both have the same denominator. And we mostly like to use the least common denominator. So what denominator can we change both a 4 and a 6 to become? And the answer is 12. Both a 4 and a 6 go into a 12. So I can change both fractions to 12 denominators. And you change denominators by multiplication. That's really important in today's lesson. So 4 times 3 is 12. And then whatever you multiply to the denominator, you have to multiply to the numerator to keep the fraction equivalent. So that'll become then 9/12. Same thing with the 5/6. 6 times 2 would make a 12. And then we also need to multiply the 5 by 2 to make equivalent fractions, and you get 10/12. Now, once you have equivalent fractions, you then may add the two numerators, and then you keep the denominator. So 9 plus 10 is 19, and it's 19/12. All right, one more of the stuff you did way long ago. 4/5 minus 3/4. Again, when you subtract, you need to have common denominators. So we have to figure out what denominator can we make both a 5 and a 4 to become. And 5 and 4 can be made into a 20. Now in problem 1, some of you guys may have thought the LCD was 24. That is a common denominator. Had you in fact used 24 for problem 1 as the denominator, that would work. But in the end, you would most definitely have to reduce the final answer. When you pick the lowest common denominator, you may or may not have to reduce at the end. Okay, so on problem 2, it's a 20. So again, we change the fraction completely by keeping it the same fraction. So if I multiply the 5 by 4 to make a 20, I need to multiply the 4 on the numerator by 4 also to keep equivalent fractions. That's 16/20. And then 4 times 5 to make 20. Also multiplying the numerator by 5 to keep equivalent fraction, I get 15. And then I keep the denominator, and you subtract the two numerators. And 1/20 does not reduce, so that is my final answer. Okay, so now our rational expressions, remember, are our fractions that have denominators that have a variable in them. So if we look at problem number 3, I have to somehow add 5/6x plus 4/9x. And this is no different than problems 1 and 2, except there are variables involved. So the key concept that when I add fractions, I need to create a common denominator. So I need to get a 6x and a 9x denominator to be the same. All right. So thinking about the numbers first, 6 and 9 both can be made into an 18. And then the x's can't just drop off. They have to still stay. A least common denominator means to pull apart the least factors I need to get the denominators the same. So 6x can be changed to an 18x by multiplying by 3. And then a 9x can change to an 18x by multiplying by 2. So again, going back to the first fraction, if I multiply the denominator by 3, I multiply the numerator by 3, and that gives me 15 then over 18x. The second fraction, 9x times 2, I have to also multiply the 4 by 2, and I get 8. My common denominator is 18x. I keep that. And then 15 plus 8 is 23. And then 23 over 18 cannot be reduced. So that is my final answer. All right, and then one last use what you know. And you did do problem 3 back in Algebra 1 and also problem 4 in Algebra 1. So how do I make an x minus 3 and a 4x minus 12 have a common denominator? So this one, some of you guys might see right now how to change the denominators to be the same, and others of you might need to actually factor the second denominator. Again, all you're doing is trying to get the like factors in the denominator. So by maybe factoring out the left denominator and taking out a GCF of a 4, you now might see that both fractions have a denominator that has an x minus 3 in it. The only difference is that you need a 4 factor multiplied into the group. So if you multiply a 4 factor to the denominator of the right fraction, you will then have common denominators. And then whatever you do to the one denominator, you must also do to the other denominator, or other numerator, excuse me. So your least common denominator is going to be 4 times x minus 3. And you can leave them in factored form, just like in the multiplying and dividing exercises. We didn't necessarily multiply them back. You don't have to multiply them back. 4 times 3 is 12, and then minus 5. Now, however, you would have to multiply the numerators. Because the two numerators have to be combined, you cannot leave them in factored form if there is a problem like that. Okay, so the two numerators, 12 take away 5 is 7, and your denominator stays the same. And then 7 over 4 times x minus 3 cannot be reduced, so that is your final answer. Okay, so let's go ahead and do some newer problems now, and they're going to seem similar. Some of the denominators might get more complicated. I'll try to color code to help you see the denominators. Problem number 1, 5 over x minus 3 plus 1 over x. So again, it's adding fractions, and once you see adding fractions, you need to know LCD. Okay, so I need a common denominator. The key, I want to just point out a key mistake a lot of students do. A lot of students think the LCD is x minus 3. Do not write this. X minus 3 is not the LCD because you have to change denominators by multiplying. So how do you multiply an x to get to an x minus 3? A lot of students will just say, I'll just subtract a 3. But again, going back to what we just did, you can't just subtract things off. You need to change denominators by multiplication. So this would be entirely incorrect. All right, so how do we change it? Well, if I look at x minus 3, I can't factor it, so that's the only factor I have. And if I look at x, there is nothing I can do to multiply to get an x to become an x minus 3. So therefore, if worst case comes to worst, a denominator can always be made by multiplying the two denominators together. So if I multiply the x with the x minus 3, I will then have a common denominator. Okay, so in the first fraction, we multiplied an x minus 3 with an x. So that means I need to multiply the numerator also with an x. And that's going to make 5 times x, which is 5x. In the second denominator, I need to multiply an x minus 3 so the two denominators become the same. And that means I need to multiply that as well to the numerator. And 1 times x minus 3 is x minus 3. Okay, once I have common denominators, I now can go ahead and keep the denominator. And now when I multiply, when I add the fractions together, the two numerators, I now have some like terms that I can combine. The 5x plus the x are like terms, and that will be 4x. And the minus 3 does not have any like terms to go with it, so I just tag that on. 4x take away 3 cannot be factored, so I cannot reduce anymore. That is my final answer. Second problem. Let's see, 2x minus 6 and 4x minus 12. That's a little bit harder to see what the denominator is. Some of you guys might be able to see it right now. For others, I'm going to factor it. So we have a 2 and an x minus 3 in the one denominator. We have a 4 and an x minus 3 in the other denominator. Now they both have an x minus 3 factor in each. That means that is definitely going to be part of our least common denominator. The only thing that we need to do is the 2 and the 4, we need to create a common denominator with that. And a 2 and a 4, I can easily change the 2 to a 4 by multiplying by 2. So if I multiply this by 2, I also have to multiply the numerator by 2. All right, so that means the common denominator is going to be the 4 times x minus 3. So the numerator of the first fraction, you have to multiply a 2 with the whole entire numerator. So that's going to require you to distribute, and that's going to give you 2x take away 10. The second numerator did not change because the denominator didn't change, the numerator will not change. So this will stay x minus 7. The other problems we worked with subtraction, we only had one term, but in this problem we have 2 terms in each. You have to be careful when you are subtracting 2 terms that you subtract both of them. So in order to make sure that we don't make that mistake, really all subtraction is adding the opposite. So we can change the minus sign to a plus sign if we add the opposites, meaning change the signs of the terms being subtracted. If you do that, it'll save you from making the mistake. A lot of students forget to subtract the negative 7. So by changing it to adding, makes the problem now a little bit easier as far as I don't have to remember as much. And now I can just keep the denominator and add the 2 numerators. So my 2x, and now I change it to plus negative x. That is going to make an x. And then I have to then add my other 2, negative 10, and now it's a positive 7. And that's going to add up to negative 3. And then I look at my final answer, and then this goes back to day 1. How do you simplify a fraction? You cancel out like terms. X minus 3 are like factors. X minus 3 and x minus 3 are like factors. So this group of factors and that factor can cancel out. And when you cancel, don't forget, it's really a 1. So when everything's gone, there's a 1 over 4 left. So that subtraction means that it always is equal to 1/4. Okay, the next problem, example 3, y minus 5 and 5 minus y. Yes, you could multiply the one denominator or both denominators together to create a common denominator. But if you recall, this looks really, really familiar. Y minus 5 and 5 minus y almost look the same, but not quite. But if you recall from simplifying fractions, when you have a group of factors that are just reversed in using subtraction, they are really opposites. So you can flip the 1 around if you times it by negative 1. All right, so if you multiply by negative 1, and again, I'll just erase that now. If you multiply this by negative 1, you're just saying to reverse it, make it its opposite. So that'll become y minus 5, and the numerator become negative 10. The other denominator is the same. And so the numerator stays the same. So this is really an important example because this is actually tested a lot on the regions. So again, look out for the factors that are just reversed of each other with subtraction. Just flip it around by basically multiplying by -1. All right, once we do that, we now have an easy problem because now we have common denominators. So we keep the denominator, and then we add the numerators. And 2y plus -10 are not like terms, so we'll just write them together. And at this point, the adding part is done. Now we just have to see if it can break down. So we'll try to factor it and see if there are any like terms. There is a GCF of a 2. Factor out the 2, you get y minus 5. And they both have a y minus 5 factor in each numerator and denominator. And that reduces to 10, or 2, excuse me. All right, example 4. What is the common denominator? So this one is a little bit harder to see. Again, if you cannot tell what the common denominator is, try factoring them to see all the factors, and then all we have to do is figure out what missing factors do we need to include in both denominators to get them to be the same. So x squared take away 4 can factor to be x plus 2 times x minus 2. All right, both denominators have an x plus 2 factor in them. So by factoring it apart, you can see all we're missing on the left-hand denominator is this x minus 2 factor. So if I multiply that x minus 2 factor here, those denominators will be the same. And whatever I multiply to the one denominator, I have to multiply to the numerator to keep the fraction equivalent. Okay, so the common denominator for this problem is x minus 2 times x plus 2. All right, the numerator of the left hand, I have to distribute because I'm multiplying an x with an x minus 2, and that'll make x squared minus 2x. And the numerator of the second fraction I don't have to change because I did not change the denominator. That will stay 8. Okay, so because there's only one term in the second fraction, I don't need to change the signs. I can leave that. You really want to make sure that you change the signs of subtraction if there's 2 or more terms in the second side being subtracted. All right, so we have now common denominator. We're going to keep the denominator. And the two numerators, x squared minus 2x take away 8, they're all unlike terms, so we'll just string them together. And now at this point, I have to see if I can reduce. So in order to do that, I have to see the factors to see if I can cancel anything out. This is a try. It does factor. What multiplies to -8 and adds up to -2. It's -4 and +2. All right, the denominator stays. They both have an x plus 2 factor in the denominator and the numerator, so crossing them out. My final answer then is x minus 4 over x minus 2. All right, we'll try 2 more problems together and then have you try some on your own. All right, problem 5. Y plus 3 and y squared minus 9 are the two denominators, and I'm subtracting, so I need to get them to be the same. All right, I can't tell, so I'm going to factor. So that is a dots, y plus 3 times y minus 3. And looking at the two denominators, I see that I both have a y plus 3 group in it, and all I'm missing is a y minus 3 group in the first fraction. So I'm going to multiply a y minus 3 to the first fraction, which means I now have to multiply a y minus 3 to the numerator. Your common denominator is y minus 3, y plus 3. And then your numerator of the first fraction you have to distribute. So you'll get 4y minus 12. The second fraction's numerator is not going to change because we did not change the denominator. All right, because we're subtracting it, and we have two terms, I'm going to change it to adding the opposites. That's what subtraction is. And now I can go ahead and add the two numerators, and you keep the denominator. So I'll keep the denominator. All right, adding like terms, the two numerators, I have 4y plus a negative y, which is 3y. Okay, we have a negative 12 and a positive 3. That's going to be negative 9. All right, and at this part, the adding fractions step is done. All we have to do now is see if we can simplify. And let's see, this is a GCF. So factoring out the 3. The numerator is already, or the denominator is already done. All right, they both have a y minus 3 factor in each. Reducing that out, we have a 3 in the numerator and a y plus 3 in the denominator. And remember, you cannot cross off those two 3's. Y plus 3 is a group and 3 is a group. They're not the same groups. Do not reduce. All right, one more, and then I'll have you guys try some on your own. Problem 6, really hard to maybe tell what the common denominator is, so I'm going to factor this out. X squared plus 7x plus 12 factors to be x plus 4 times x plus 3. Both denominators have an x plus 4 group in it. All we're missing is the x plus 3 group. So I'm going to have to add or multiply that into x plus 4. And if I multiply x plus 3 to the denominator, I have to also multiply x plus 3 to the numerator. So the first fraction is going to be kept the same because we're keeping the denominator the same. The second fraction now will change denominators to x plus 4 times x plus 3. And then I'm just going to have to distribute the numerator. And I'll get 2x plus 6. Okay, once I have both denominators the same, keep the denominator. And then add the two numerators together. So we have, because we're adding, x plus 2x makes 3x. And we have the 6 plus 6 will be 12. And now we have to see if this can reduce. The adding part is done. Now we have to reduce. And it may not reduce. I've been giving you a lot that can, but it may not. Let's see. There's a 3 factor in the numerator. The denominator is already factored. There are, in fact, common factors of x plus 4. So factoring them out, I get 3 over x plus 3, which is basically almost the answer we got in 5. That was pretty neat. Okay, so now you're going to be doing problems 3, 4, and 5 on your own on the practice pages. You can pause the video and try to do them, and then I will be doing the work, and you can compare your answers, see how well you did. So please pause it and do the 3 problems on your own. When you do a plus negative, it's just going to be a negative. All right, make sure to factor completely. This is now dots. It was GCF. And you can leave your answer in the factored form. You don't have to multiply that back together. Okay, now we just got to see if we can reduce. All right, hopefully you did well on those 3 problems.